Hey Manny, how you doing?
Hey, this is Mayank.
Oh, Mayank, I'm sorry. It's been a couple meetings.
Yeah.
Oh, glad you're back in. Cool. Hey Suji.
Hey, hey, Frank.
Hey, Sujit.
All right. Yeah. Sorry, I was a bit late. I was actually reading through, well, actually looking at the Metaverse Twitter post from Facebook.
Oh, what is that?
It's actually quite a nice one. I can post the link.
Oh, what is Metaverse?
Oh, they changed their name, right?
Oh, it's a company.
Yeah.
Oh,
They changed their name to, Facebook changed their name to Meta. And the reason they changed their name is,
wait a minute. Facebook, I heard something about, did they seriously change their name?
yeah,
What company?
Yeah.
That's insane.
yeah, I think their products are still going to be called Facebook or, Instagram or whatever, or WhatsApp, right? But it's like the Google alphabet kind of thing. It becomes
Yeah.
like a top level thing.
Yeah, that's what I was
Also,
thinking. Exactly. Okay.
yeah, also meta.org, which is from the Chan Zuckerberg Institute, right? They're shutting down. So I think they're trying to revamp. They're going to, they're doing a Microsoft. You know how Bill Gates was like not really well liked at one point. And
Yeah, they want to get out from under that
Right.
that brand is what they want to do, right? Because they have bigger ambitions than just.
Yeah, that brand has a lot of negative weight these days, doesn't it?
Yeah.
And say anything else interesting?
But no, it's actually a nice. I put in a lot of tracking information, so you can take that off. But just it's a nice jingle and whatnot. And they talk about the metaverse and the next step in their social network thing. It's going to be more like a Second Life kind of deal, right? You will have an avatar and you'll be able to move into different worlds and teleport between worlds and so on. So that's where they're trying to go. More virtual reality kind of deal.
Yep. All right, what else going? I guess we ought to start just by saying, does anybody have anything that they before we just sort of go around and update each other? Is there anything anyone wants to start off with, or make sure that we get to talk about, or maybe you have a question you want to ask up front so we don't run out of time for your question? Mayank, you have anything like that we should start off with?
Not at the top of my mind.
Okay. Anyone else? Yuri, you have one of those? Or otherwise we'll just go in circles and I'll start. Okay. And CG?
I had that data augmentation paper that I presented internally. So I'd already did the work. If you guys want, and if there is time, I can go through that.
Yeah, we could just we could start with that if you guys want. Does anyone have anything they want to do before that? Yeah, that would be great. You did mention that last time as well. So if you'd like to do that.
Okay. Give me a sec to bring up my notes and the paper. Then I can do that. And meanwhile, I mean, if there is, if people have anything, then maybe we should finish that first.
Well, so I don't have anything big. I have little teeny things. There was one, so this is just a teeny thing while you're getting ready. CG. Yeah. There, I did attend just a handful of the graph. There was a graph conference. I forget the name of the damn thing now. This past week. And in that graph conference,
knowledge forum.
Yeah, knowledge forum. So it's people who are doing like a lot of them out of the database world, but they're doing knowledge graphs. So it's knowledge graph conference. And I sort of just popped in and out of a couple of things. One thing I found that was interesting to me, I don't know how interesting to you guys, but there's a tool called Meta Facts. And it's interesting because, let me post it. It's inexpensive and it's easy to use. And that is Meta Facts. And what it is, it's like currently at my work, we use a really good taxonomy management tool that specializes for taxonomy management called Pool Party. You know, like you have a pool party, all one word. And they're great for taxonomy management. And, you know, they sit on top of different databases, you know, use a triple store of one kind or another usually. But, you know, and then you export and import to integrate it with your other processes and things. So that to me is exactly what MetaFacts is, but instead of coming out of the content taxonomy world, it's really natively a graph tool. So what it allows, a graph and ontologies, but it's very simple though, and good GUI. And so it's very easy. What they did a demo where you quickly can create your schema, which of course a lot of graph databases don't have a schema, right? So it's obviously sort of more RDF directed, but you basically can create your entities and then connect them based on fields and IDs. And it's very simple and visual. And then you import, they just imported CSVs, but you can import from any sources, and then it populates the knowledge graph. And then you could really, within a matter of minutes, have a very simple knowledge graph up and running for your company. And then you can query it, and it has an API, but really you can also export it. You can export it into the ontology RDF world, or you export it into the graph world and put it into, you know, Neo4j or something like that. So it's very analogous to the taxonomy management tool I use. It's just a very good way of creating a graph that you could do stuff with. So anyway, a knowledge graph specifically, because knowledge graphs really are entities. You identify your key entities. There's usually not a ton of them, and then you ID how they're linked, and then you use it to integrate your structured data and your content. So anyway, that's it.
Okay. This is cool. I was looking through this.
Yeah, I mean, it's showing you the industry's maturing, right?
Right,
From
right.
a world of, especially knowledge graphs, a world of either complex ontology, RDF semantic stuff, or a world of complex large enterprise data integration, right?
Right.
It's maturing, and this is an interesting indicator of that to me. So
The ontotext guys are actually, like, you know, they combine NLP and graphs quite well.
you're wondering if they do that?
The ontotext guys, the guys who were, you know, behind that, the conference that you went to, right?
Yeah, Ontotext, those guys have been around for a long time,
Right.
right? They're like come out of the semantic web stuff, maybe earlier, like Protege. Yeah, they're a more sophisticated group for sure than the MetaFacts stuff. But yeah, I do wonder over the years how much they've incorporated the ML stuff, right? The graph ML.
Right. Yeah. Yeah.
Do you have any ideas? Have you ever used Ontotext?
No, I haven't actually used. I attended a few of their things, you know, their talks. I like it, but it's another graph platform, right? I kind of, at work, I use HGraph, not HGraph, sorry, GraphDB, which is more RDF based, and also Neo4j. So, you know, it's another learning curve to deal with. So I haven't actually.
So I only listened to like few talks in this whenever I could in this conference. I thought GraphDB and Ontotext is the same thing. I don't know. Maybe I did.
No.
Maybe I didn't.
Yeah, you know, GraphDB is one of their products, I think.
Is there?
I think it is. Yeah, I think you're right. I heard that
Okay,
too.
maybe. Okay.
Yeah.
Funny, because I was surprised when I saw that too.
Okay, so yeah, we use
Sorry.
GraphDB, but we don't use anything else. But I don't. We don't actually use their text stuff, as far as I know.
Oh, okay.
Mike,
I thought there was a really interesting announcement from Wikidata in this conference that they basically now you'll be able to commercially buy Wikidata. I mean, you can always use it, but they're going to actually support you now.
You know, I heard
So-
a podcast with the Wikidata, the guy who's doing all that. I don't know if it's the same guy that presented. And they do a lot of interesting machine learning and graph work. Yeah, I can't remember it now, but yeah, fuck. Very useful to say. It was stuff about edits, like automatically detecting. It was all supporting the edits, you know, the people that edit and maintain Wikipedia, and auto-identifying, you know, bad stuff so that they could focus on it. But anyway, what else, Yuri? Is that pretty much what you saw?
Yeah, like I keep, I think now we get access. I think I'll post a link to the conference. I don't know if you can get access. I think you can probably still register and get access. I think they said the videos will be there for 2 months.
Right.
So I'll go through them. Yeah, like I'm still like pretty busy at work, so I didn't have a lot of time.
Yep.
Yeah, but Wikidata is so we have a big ontology group now, and they're all excited. They're already like, you know, they're already connected. They run already Sparkle queries against Wikidata and trying to like see if they can get enough, you know, data to justify using it.
So what was the announcement again in the conference?
Yeah, so Wikidata was always available, but now you can actually buy the support. So you get like dedicated support, API rate. You'll get notifications when something changes. So you can use it as a paid service. Basically, you can basically reliably get the data.
Yeah, that makes sense. That's been around a long time, actually, Wikidata, where you can query it. So it's about time they do that. That's cool. Okay, I see, Manny, you joined. Did you have anything burning that you want to make sure you get answered, or sure, because we're about to have Sujit's about to do a little.
No, I don't have a lot today. So I was looking forward to what Sujit for the data augmentation. Yeah.
Okay, let's go for it. If you're ready, you ready?
Yeah, I'm ready. Let me share my screen. Yeah, I was going through this thing. Oh, wait. Zoom, right. Okay. Share screen. And, oh, so we have everything there. Okay, cool. Yeah, I would actually, I realized though, thank you, Yuri. I didn't actually realize OntoText and GraphDB are the same guys. Yeah. Oh. So this is the paper I was talking about. And here are my notes. I can post a link to it in case anybody is interested. It probably makes it easier to go through. So one thing to realize is that this is visible, right?
Yes, the
Yes.
paper, yes.
All right. So one thing to realize is that there has been other survey papers like this before, and this is one of different survey papers on data augmentation approaches in NLP, and so they bring their own spin into it, and basically at a high level, they're saying that you can classify them like a very high level taxonomy as paraphrase based, noising based, and sampling based, right? So paraphrasing based is you basically generate paraphrases of original data, like chunks of data. Could be tokens, could be phrases, could be sentences. And the idea is that because this whole paraphrasing thing is very tight, right? So it's quite precise, high precision, low recall. So there is limited semantic difference from the original. There is actually, any semantic difference is controllable by you, right? By the rules that you are using, or the paraphrasing technique that you're using. The noising based is basically adding and deleting tokens. Again, tokens could be phrases, words, and it could be sentences, depending on the size of the document you're using, right? And sampling based is basically learning generative models, not necessarily generative models, but it could also be rule-based generative models. But you basically learn the distribution of the data, and then you use the distribution to generate new data, right? And so this is the three methods. And then what he's done is that for the paraphrase based, he's classified it by structure, right? So, oh wait, so this one is a nice diagram he's got. So each of these different techniques he's talked about at a high level. Well, this is actually not as detailed as another table he has further down, but he basically identifies the main papers for each technique and sub-technique, right? So this is quite interesting. I mean, you could go through these papers individually, but it's like a nice overview, right? And here he talks about the paraphrasing based methods. So you have, you can either classify it by structure or you can classify it by technique, right? And so these, the 1, 2, 3, right? These are the classification by technique, and the circles are basically classifying it by structure. So when you classify by structure, you could be like lexical paraphrases, phrasal paraphrases, or sentential paraphrases. Mainly the size of the text chunk that you use, right? So on the techniques itself, so you have the Thesaurus technique where you can use WordNet and or any other kind of dictionary. So basically, you take synonyms and you you select words that you want to replace, and then using WordNet you select their synonyms, and then they're talking about a geometric distribution here, where you basically take it's kind of like an exponential weighting kind of deal here. Let's see where the query. Semantic embedding is not here. I think he talks, oh, here. So he says the probability of the audit element, right, is determined by the geometric distribution with a parameter p, is p to the power r, right? And so essentially you're saying that, the first word is, replaced with the highest probability, then the next word is replaced with the lower and lower probabilities. And so that's one approach to doing it. There is also a technique called easy data augmentation, which you basically choose n words that are not stop words at random, and you replace with WordNet synonyms, right? Again, you just, the selection is basically at random, the n words, right? Another spin on that is to use hypernyms as well as synonyms. And there is another, further down, they have another approach where the choice of words is in terms of increasing difficulty, and it uses part of speech to figure that out. So adverbs are the least difficult. So you first choose adverbs, and then you choose adjectives, then you choose nouns, and then you choose verbs to replace, basically, right? And then use words in the same category in addition to synonyms and hypernyms. So there is also another approach here, which the synonyms recommend the types of words that are candidate lexical substitution. Okay, not this one. Retrieve synonyms. Oh, and words of the same category. So basically, they're saying like part of speech kind of things. So the created things may not necessarily, be identifiable as the original, right? The augmented sentences might look very, very different, but largely paraphrases keep it, so it says here, it's the scope is kind of limited and it does not solve problems of ambiguity. And yeah, and if you have too many replacements, it can make the sentence look weird. Okay, the second one is semantic embedding. So instead of using something like WordNet, you basically use like a word embedding, word2vec or glove or whatever. And basically you find the k closest words in vector space and you replace by one of them. And you can also, so there is a spin here with you can do frame embeddings. So essentially you can figure out what the semantic frames of a sentence, and then replace the frames with one of the k closest frames. Again, you have to create a embedding of frames in that case, right? Frames are basically just chunks of like intelligible chunks of a set of words. And compared to thesaurus based, obviously semantic embeddings have higher recall, and they're easier to use, and again, it's like more recall than this, but this is more easier to use as well, because you can get more. You don't have to mess around with specific synonym dictionaries and so on. But they still don't handle the problem of ambiguous words, right? So, and that's where the language models come in, where so you basically use BERT instead of BERT and friends instead of word-to-vec kind of things. So you get the word embedding in the context of the sentence, right? So addresses ambiguities in sentence, obviously ambiguity is addressed in this case. You can also use MLM directly, masked language modeling. So you basically mask out the words that you want to replace, and then you run MLM and take the predictions, and you just swap them with the, the predicted words. And language models. So limitations are, it's still limited to word levels, and the sentence semantics might be affected. Okay, that's normal. But it alleviates the problem of ambiguity and makes it context specific. And finally, you have rules, and they kind of use the heuristics about natural language. Some of them are just lexical, so they take word contractions and replace it by the expanded version, or vice versa, depending on what you want to do. And you have basically dictionaries, right? So you take these phrase dictionaries, and you just take the left hand side, you find it, and you make it the right hand side. Basically normalization, right? And there is also another one. Okay, maybe it's further down, the PPDB. Okay, sentence level paraphrases using dependency trees. So essentially, what you do here is that you construct a dependency tree, and then you use dependency tree transforms to construct another dependency tree, and you generate the sentence from that. And this could be done, things like active to passive voice, or you can, switch subject and object, right? And the pros and cons are that it preserves original sentence semantics, but again, cons are low coverage. Then there is machine translation, and I had originally only thought of back translation as a viable method, but here he points out that unidirectional translation can also happen, where if you're trying to take data from a high resource language into a low resource language, right? So there is the famous example of Facebook, where they were forced to look at Burmese, which is a low resource language, in the wake of the Rohingya issues, right? The massacres of Rohingyas. So, and Facebook did not have the resources to basically look at the Facebook post at that point, and a lot of the hate was being spread by Facebook. So that's when they actually used this technique, where they took English language and they translated it using English to Burmese translation software, and they got data to basically work on the Burmese language. So that's another one. So, and back translation is basically like you have sentences in a bunch of sentences, maybe say English, you translate it to Russian and then back, Arabic and then back, French and then back and whatnot, and each time you get a little bit of variation. So, and you could add that as your augmented data set. And there is obviously you can use temperature settings to control how much various how much leeway you're going to offer the translator, right? Translation. So each time you make, you raise the temperature, the translated version becomes a little different, and you raise the temperature back, and so the variation between your original and the back translator stuff is more and more different. And there is also, so sometimes the quality goes like really bad, right? So in that case, you could use GAN style or basic classifier style discriminators, which basically filter out back translated sentences that are too low quality, right? Too different from the basic one, the input. And so this is about machine translation. Unidirectional and bidirectional we already talked about. Easy to use because you can just use off-the-shelf stuff, right? Although the discriminator you would have to train yourself if you needed to use that. And poor controllability, limited diversity. Sure, I mean, you could make the case that it also adds noise, and makes the model more robust, the training data more robust, or for to help with more creating more robust models. And then there is the last bit where you basically train a sequence-to-sequence model to generate paraphrases directly. Machine translator systems are sequence-to-sequence models generally. So you could just, instead of doing this whole back translation game, you could just make it, train the encoder to basically create representations that the decoder can use to generate paraphrases directly. So this has been used in dialogue tasks where you could generate new utterances given an input utterance. And here, then you could also use transformers. Some people have used transformers, as you can see here. And the pros of this is that you get strong diversity and application specific, because you have trained the paraphrase model to create your paraphrases. And the limitation obviously is that somebody has to get the training data. Sequence-to-sequence models are reasonably difficult to train. So not necessarily very difficult, but depending on your data. So the second part is the second big technique that they cover is the noise-based, and they're basically just swapping, deletion, insertion, substitution, and mix-up, right? So all these, the swapping, so the first 1, 2, 3, 4, swapping, deletion, insertion, and substitution, basically are textual things, right? So what you do is, in case of swapping, you basically take, so the idea is that, depending on your input text chunk, so if your input text chunk is a document, you're okay to swap sentences. If your input text chunk is a sentence, then you typically would swap, either tokens or phrases, right? And so you basically, depending on the size of your input, you select 2 words or 2 sentences randomly, and you just swap them and repeat n times where n is proportional to sentence length. And the fear here is that the final sentence, the augmented sentence, can look very different from your input sentence. And again, this is justified because in a lot of cases, your models are trained on bags of words or bags of sentences rather than, sequence probably doesn't matter as much. And so, it works out that way. So you can also do, tokens into segments and then randomly choose segments to shuffle the token order. Let's go back here. Noise and swapping, okay. And then you can also do instance and sentence level swapping. So there is one case here they cover where they took a Twitter corpus and they split it up into halves, each tweet, and then they randomly mixed and matched the halves to create new tweets. And I think what they did was they took tweets of the same sentiment. So they were doing sentiment classification, I think. So they took all the positive sentences, split them in half, and then created new ones composed of, random combinations of the 2 halves among all the positives, and do the same thing with the negatives. So and essentially, since sentiment classifiers basically deal with bags of words, it kind of works out, right? So you get more label data. And
quick question, Sajid.
Yeah.
So the data augmentation approach that you choose should be based on the the model that we are using and the task at hand.
Yes.
Okay.
Yeah, a lot of it is like, I think it's bottled common sense, really. But it's nice to have a kind of a catalog of things to choose from, right? So in that sense, the survey paper is useful. You might not learn a whole lot. I learned about the mix-up. One of that was the main thing that I learned about. I hadn't thought of mix-up in quite that level of detail, that that you can basically interpolate in the space and so on. It's in this noising based thing itself. So that's the only one which is embedding based. so again, here, oh, okay. So swapping we already covered. Deletion is basically randomly deleting words and just not doing anything else. And you can do the same things with it. Insertion is randomly inserting words and not doing it. It's very similar to substitution, right? And the only thing here is that as you insert more stuff, you can move away from the original meaning. So you have to be kind of clear as to, okay, yeah. And there is also, yeah, okay. There is also, we did swapping, right? Okay. So there is a little difference with the substitution. Here, they basically, replace with misspellings. They do, word dropout. Basically, they replace random words with unc kind of tokens. Then you can use parallel corpora. So here, substitution is kind of different from swapping because you're trying to use similar words, right? So you keep the sense the same. So again, if you have NERs, then you can replace with NER, same NER label you can replace with other tokens. And yeah, again, slot labels. And so this is basically all the textual ones. Mix-up, you basically take the embedding and you one of the assumptions you make in this mix-up is that, if you do interpolate in that space, in the feature representation space, you also interpolate similarly in the target space, right? So not only does your, so as you create new augmented data, you also create new augmented labels, right? So, you basically say that, whatever weights that you have here between one point in this space and another point in the space corresponding. So if it's word to vec, then it's corresponding to tokens. And you basically interpolate between them. You also interpolate between the labels of that space. So whatever probability that it was giving you for a particular, the probability distribution that it was giving you for the output, you should be able to get a new probability distribution when you softmax it. And
is this similar to label smoothing, like you talked about?
Yes, yes. So you can get basically, your augmented stuff need not. I think you get more freedom to augment stuff, and then you just have a new label if necessary. It doesn't have to be restricted to you don't have so many constraints when you get when you have to create new augmented data. So anyway, that was yeah. So it's very popular nowadays, and like you, Mani actually pointed out another paper which was talking about mix-up exclusively. So yeah, and sampling based is okay. So you basically learn the data distribution. However, so initially when I thought about sampling based, I always thought about deep learning based things, right? So GPT-3 or GPT-2 or whatever. Basically, the things that can learn the distribution and then spit out stuff, right? Even VAs, but there are non-DL approaches as well, right? So one of them is simple rules like if you do chunking, you can just swap the subject object, or you can do active to passive using rule-based kind of things, using sentence structure. You can use external ontology like PPDB, paraphrase database, and artificial heuristics. Basically, with paraphrase database, you look at parts of phrasal constructs like let's say we can think of some phrase. As of now, for instance, right? How many other ways can you say as of now? So you could look up PPDB and find the equivalents for that, and you just pop that into your sentence, right? So and then there is also this is kind of a more complex kind of thing. So you can find sentence pieces or sequences of part of speeches which are conducive to create positive and negative pairs, right, for augmentation. So if you see an adjective noun and a noun pair, so for instance, fast car and a car, this is really good for, you can say slow car and car, right? However, if you see two adjective nouns side by side, like fast car and red car, then you cannot really use this rule to, make this augmentation, right? So there are these little constraint kind of rules. There's more examples in the sampling-based text here. So I didn't actually go through it too much in detail because I don't want to use this kind of thing that much. But there are other ways to do here. So, car, the construct fast car. And then there is also non-paraphraseantation through three properties: reflexibility, symmetry, and transitive extension. There's a paper reference. So, in case I ever want to go there, I will look at the paper, but I didn't, so I didn't. And so the next bit is sequence to sequence. We already have seen this. Pseudo parallel sequences using trained sequence model. So essentially, if you have a trained sequence model, you can construct basically, it's like the paraphrase thing that we talked about, right? Other possibilities are transformer based in VAE. VAE has the nice approach that you don't actually need training data, it's unsupervised. Transformers is also, it's kind of self-supervised if you want to train it, or if you can take a trained transformer, that can help a lot. And there are some approaches here, and here is a diagram basically which kind of summarizes this whole thing. How different approaches work: rules, sequence, language models, and self-training. This is another thing I learned, self-training. I didn't know this word before, but it's actually quite not that, we all know what it is. I just didn't know the name of the thing. Okay, sequence is done. So language models are, so basically, again, it's using pre-trained language models. And so there are some, architectures here. One is called Lambda, which uses a fine-tuned GPT-2 to generate labeled augmented sentences. And it's filtered by a classifier trained on a small gold set to ensure quality. So, you basically, I think this one, the Lambda was for a particular task. I don't remember what it was. Labeled augmented sentences will fine-tuned on the training set in advance. Okay, so the GPT-2 is fine-tuned on the training set, and then the augmented sentences are also filtered by a classifier, which is also trained with the training set. And basically, whatever the GPT-2 gives out is kind of filtered for goodness of fit. Right? There is another one where it says uses the corruption and reconstruction model. So it generates data which is far away from the original using a corruption model. Here. So Ying et al. Used the masked language model to construct a corruption model and a reconstruction model. Given the input data points, they initially generate data far away from the manifold. And then the reconstruction model is used to pull the data back to the original data method as the final image. So I think the first bit is to ensure that noise is injected and kind of regularize the input, and then you pull it back towards the manifold using the other model. And there are popular models used here are GPT-2 and Distilbert. So yeah, and so the self-training, which so essentially what you do is you have a little bit of gold data, you train your model using that, and then you apply the model on your unlabeled data set to generate a bunch of silver data, basically, right? And then you apply data distillation on the silver data to retain the augmented data with high confidence, basically, right? So here you have like a teacher model. So let me actually show you that picture. The picture is more useful to copy link URL. here, this one. Okay. So here they use glue to basically teach the, create a teacher model, right? And then they use this teacher model using, they use this teacher model to basically run against a large set of unannotated data, unlabeled data, and create labels. They combine the glue and the outputs, the gold and the silver data basically. And then they use that to train a student model, right? And they use the output of, the student model is basically used henceforth. And that's basically what their deal is here with the centaugment. And another approach that has been used is to extract triples from Wikipedia and basically flip the triples using and generate new sentences using RDF to text. So basically your subject becomes the object and your object becomes the subject. So, say smoking causes cancer, like really simple idea. Smoking causes cancer becomes cancer is caused by smoking, or cancer is due to smoking, or something. It's a, And so now he goes into an analysis and he talks about the different methods. And, like most of it is covered in the pros and cons kind of thing. But it's basically, this is a, he basically goes and covers this whole thing, right? It's, I don't know if this is like a lot of, it's there. I mean, he's written a paper, so he's got filler stuff in there. I think the next bit that is more interesting is the strategies that he's talked about. So one strategy is basically, method stacking. So, so you use more than one method to generate augmented data. So the typical approaches are using the same type of methods. So, usually combine different paraphrasing methods to obtain different paraphrases. And so I think the only thing he talks about is different paraphrase methods. The other approach is trying to use mostly unsupervised methods, because that's one of the attractions of data augmentation is that you can get more data. And multi-granularity, which is you apply the same method at different levels. So at the word level, at the sentence level, and so on. Or augment tokens and augment sentences, and then use both as unlabeled data. And the other thing that he talks about is training strategies, which says, optimization. So uses of augment data. So the idea here is that gold and silver data are not the same. So typically you would, oversample your gold data. If you're going to combine the two, you want to oversample the gold data, because gold data is better, right? So that you want more effect of the gold data on the training. The other approach is to pre-train on the silver data and fine-tune on the gold data, right? So the coarse grain stuff you finish off, using the silver data, and then you really fine-tune the model using the original hand-labeled or other. So basically, better, whatever the data is, gold means to you. Then he talks about training strategies, and the main ideas here combine the back translation with adversarial training. So, we already talked about this. Basically, you have a GAN on the front, or some kind of discriminator on the front. Then he talks about using reinforcement learning, and where is this? Under training strategies. Yeah, he basically, where is this? Curriculum learning. I don't see where he got the reinforcement learning. Might have been somewhere here. So the curriculum learning is another approach that I knew the name, but I didn't actually know what it was. Is essentially you start by training the model on easy training examples, and then you make it, the training examples progressively harder. So as the model gains skills, it gets trained on harder and harder, data, or better quality data, I think might be more suitable here. It kind of goes against, it's similar to this approach, right? Where you basically train on the gold data last. So it's kind of similar, but not really. So, and this is the table I was talking about, where he talks, he takes each of these methods, and then he gives you multiple paper references. We saw one right in the beginning where they had like one paper reference, but here he's got like tons of paper references, and he makes a pretty nice thing in case it was good for reference, basically, right? Applications to NLP tasks. So he says text classification, and for text classification you can use almost any of these techniques. They all work. For text generation, so okay, yeah, here. So that's where text classification is, where data augmentation is most widely applied, and any method would work fine. For text generation style applications, sampling methods are preferred because they bring in more semantic diversity, apparently. And for structure prediction, paraphrasing based methods are preferred because it's high precision, so and you need that kind of thing. Structure.
Hey, I have a related question.
Okay.
I mean, I do think that most of the time is used for like if you look at the most usage, they're for supervised learning situations, right? Where you have a training set and you're doing data. That's like 98% of the time, I'm guessing. Have you ever heard of anyone using data augmentation for classical unsupervised kind of stuff like clustering or topic modeling, or even DNN model building for unsupervised, like in Coder? And does it intuitively make any sense for an unsupervised problem other than RL?
I think maybe only for RL, because that's where you need like possible data, right? I don't think. Yeah, for things like clustering, I think it'll actually create more trouble for you, right? I mean, if you put in augmented data.
Yeah, I don't think it makes sense, but I'm just trying to make it make sense because it's interesting. It makes it clear what it's being used for.
Right.
Yeah, I mean, and then I guess my question. You go ahead and finish before I open up to an open.
Yeah, I think I'm almost done here, and basically he then concludes, and so he also talks about. So here's a bunch of related topics which kind of touches on subjects which are not central to this paper. And but there are interesting things like the one he talks about a little bit of pre-trained language models, contrastive learning, and so on. But one of the things I actually thought was nice that he kind of covers is other data manipulation methods, and basically they're oversampling, data cleaning, data weighting, data synthesis, and that's it. That's basically all it is. Data weighting is basically class weights, right? So instead of actually directly oversampling small classes, how do you call it? Underrepresented classes, you basically increase their class weights. So any changes there will have an outside effect on the optimization. Yeah, that's basically all I had.
Does anyone have any comments or questions or thoughts?
Was brilliant. Sujit, I have a question. So this is very generic, though. The part which it's hard to grok for me is, how do you balance between this scale and also ensure the quality of the data, that is augmented? That's the part. It's because after a point, we cannot actually verify if the semantics have changed, or we most likely would actually look at only the score, the metric.
I think that's where the supervised part comes in, right? So all these discriminators or the filtering methods that they're talking about, I think that involves having label data, basically saying that this is correct, this is wrong. So using that to kind of push it back into the space that you want. Throw away
It's
things
like
that you
everything
want.
else. There's hardly any even heuristics, metrics you can use. Other, you know what I mean? Like you're almost shooting in the dark. And if you could do infinite number of experiments with infinite number of data augmentation, and you just do it and see what the your output was, right? Your accuracy,
Right. Yeah.
measuring, and you just use I guess you just, unfortunately, it's about intuition, right? So you're an optimizer, optimizing the space of possible solutions, right, of augmentations. And the problem with intuition is it takes experience, right?
Yes.
And so that's, I guess it's a shitty answer, huh, Annie? I mean, that kind of sucks. So I would wonder, in that same vein, I'm wondering, has anyone here actually done data augmentation? I know, Suji, you did the
Yeah, I've used in connection with Snorkel.
reverse translation, but does anyone have any other experience? And my big question about this is, with this sort of intuition and optimizing, is that there's a billion strategies, like with balancing your data as well, and what algorithms you use, and all this label smoothing, there's a million things you can do with your model. My question is, what can I do that gives me 5% or 10% improvement? Not the 0.5%, the one, like once you have a mature model, that kind of shit matters, right?
Right.
But the main thing is, which one of these data augmentation or groups of them to use at a point where you can't even get your model to work, right? That's the big one. And then where it changes it by 30%, or whatever your metric is, or by 10% or more, or at least 5%. Does anyone have any experience in actually using data augmentation, and how much did it affect your metrics?
I have.
Because you could spend forever doing this shit.
Yes. Yeah. Some of them is as for experience, I have like very dumb model. Well, one of them is the back translation, which is not so dumb, but there have been others where where I basically ask for a small goal set, train the model, generate data, and then send it back, take another 1,000 and then send it back and say, can you please label this also, right? So it's not really, really good data augmentation. Is basically a variant of the self-learning kind of thing, the self, whatever it was.
Well, what was the data augmentation aspect of it?
Basically, so initially I asked for, say, 1,000 labeled examples, which they gave me. I use that to train my model. Then I generate another 1,000, and then I sent it back to them and say, can you please label this as well?
Wait, so the first set of labels are real documents.
Right. Where they had to start from scratch. But the second set is basically, I'm sending in labels. They just have to tell me if it's right or wrong. Right.
You're not augmenting the data, though. You're generating, yeah.
Yeah, it's kind of not really augmentation. So I've used that. Another thing that hasn't been covered here is Snorkel, which I think is another augmentation thing with the label functions, where you have naive, noisy label functions, and then you have a system figure out which ones are good and how much to weight each of them. So in that sense, I think of that as a data augmentation strategy as well, but maybe it's not. Maybe
well, it's like label smoothing. I mean,
yeah.
If you include your labels in your data, yeah, of course.
Right. Yeah.
So does anyone else have any experience actually using any form of data augmentation?
I'm mostly in the computer vision platform. it's the changing the meaning is the part which makes me worried, not not to actually try data augmentation, at least at the initial first POC concept. And then if I still, I haven't actually really tried this data augmentation. It's especially in the NLP task. Mm-hmm. One thing that I do wonder for the low resource languages, I think most of the time it's the back translation I have seen people try, especially in the low resource languages. Yeah.
Yeah, I mean, other thing with low resource languages is to find unconventional sources as well. Like from printed stuff, I've seen where they've taken like the Jesuits, you know, some tiny language somewhere, and I don't know where it was, where the Jesuits had been there forever, and they had been, you know, since like the 1700s or something, 1500s, and they actually, you know, took all of their writings from then till now and actually like scanned those from an archive.
I see.
Use them, and it actually helped them with their. Anyway, I mean, that's the funny thing about data augmentation. It's really all about data distributions. And when you talk about data distributions, you're talking about trying to get more training data, right? In general, like that, and your labels as well. So, so look, what I understand is that when should the bells be ringing in my head when I'm doing an NLP supervised learning problem, when I'm trying to build a model or train a model or whatever. And my understanding of it is, well, when you don't have enough training sets, right? You need richer just to train. You need more training sets with more language, right? So you're basically training sets aren't covering enough of the distribution. And then the second one, right, so that you could actually train and get good metrics. But then the next one is, even outside of your metrics, is robustness in real life when it's actually being used, right? Those are the two main things that would trigger me to think of data augmentation. Does anyone disagree or think either those are stupid, or come up have another one I completely missed that would, in your mind as a practitioner, make you start thinking about data augmentation for NLP?
No, I think it's mainly the small training data.
Yeah.
Or unbalanced training data, that could also be, right?
Well,
So if you,
yep.
So if you had, underrepresented classes, right? Let's say you had 1,000 labeled examples, and you had like maybe 50 of one and 500 of the other. You might want to, augment just that 50 in some way, not just oversample, but go back to your data and try to find, maybe like, maybe 500, 600 examples out of your data.
Yeah, it's interesting because if you combine this idea with active learning, you could you could also maybe use data augmentation to enhance or whatever those marginal boundary. It just seems to intuitively there might be something innovative there, right? Where you combine the active learning work to identifying the boundary cases and then somehow use data augmentation.
Right, yeah.
I don't know. Maybe that's just random association in my head.
No, definitely active learning, I think, has, well, I mean, it's kind of a related thing, but definitely, I think it can be applied in conjunction with, or, yeah.
So in order to increase our ability to intuit data augmentations in our practices, I think what we could do, if anybody, I don't want to just do this myself, I want to do it if there's enough interest, but if anybody can identify someone who's like got a lot of experience, I don't know, really academic maybe, but some kind of level of real experience with using data augmentation, I'll be glad to try to get them to come on and talk, right? So we could get more, useful information on this. Now that we sort of laid out the, Suji, you sort of laid out the land, right, or whatever, that outline. Now we want to put it in the context of our intuition. So if anyone wants to, identify somebody that I could try to contact, or a couple people, I'll do that, try to bring them in. Outside of that, if we were, there's a million things that cover an NLP. If there was super interested in this, we could do some sort of exercise, like Kaggle kind of thing or something, because it seems to me like that's the only other way, other than getting mentored by bringing someone on, is to actually, do some coding together as a team.
Right.
Paired coding. We've done that before, where we break up into little groups and do paired coding for 45 minutes or an hour and come back together and discuss. So I don't know. Any ideas? Maybe it doesn't matter. Maybe this is enough for now, but any thoughts from anyone on any of this?
Well, Facebook has been doing a lot of unsupervised work, a lot of it. Granted, their domain isn't like super specialized. It's humans talking to each other in a normal human language. But they have, people there are likely to know a lot more about unsupervised learning. I don't know who they are, but this is mainly from their direction, because LeCun is big on unsupervised and kind of steers the ship that way. So in that sense, but I don't know specific people.
All right, guys, anything else we want to talk about with data augmentation specifically before we move on?
Do they mention anything about test time augmentation? Does it even make sense with the NLP? Because this
at
is
the test time.
Yeah.
Yeah, I think I would prefer to not augment at test time myself.
That's what I don't know whether it would make sense or
Augment at test time? You mean like testing your model to see if
with augmented data.
process?
Yeah. I don't think that would make sense. Maybe it does. Maybe for robustness, maybe you could try it, right?
Yeah, I mean, I have that's one of those last trick one would try, before submitting to Kaggle, at least in the computer vision test time augmentation. But I don't know if it would make sense. I haven't tried it, and then it'll be.
What would you do with test time augmentation? Would it just be trying to show how robust your model is when you submit it?
Yeah. So if you're given, say, like a test set, right? Test set for testing your stuff before you submit, right? You augment that test set and create variations of that, and your model should satisfy, have similar performance on the augmented set.
Yeah. So I get that. That's robustness. You're trying to make it. Yeah, because you don't know you're blindly submitting, and a lot of times you get bad scores. Yeah, when you submit. That's it. Yeah, I mean, that's obviously analogous to being in a company and publishing a model and seeing how it performs, and you know what I mean, and trying to make it more robust. Well, all these techniques can be used in that. All right, anything else on data augmentation? All right. Well, I guess we could just go around here. Yuri, what you been up to? Anything new at work, or anything new you attended or heard about, or anything like that?
Actually, can you go to somebody else? I'll be back in a minute.
Okay, of course. Mike?
Yeah, I came across a library, NLP Argument. That's a data augmentation library for NLP.
Nice.
Yeah. I just posted a link in the chat.
Yeah, the author of that library might be a good candidate.
Yeah, absolutely. Yeah.
That's interesting. Yeah. Huh. Well, you guys just gave me a job. NLP Aug. Oh, I've never heard of that. Is it pretty new, or did I just miss it? Let me see.
It also provides augmentation for audio and other spectrograms too.
Nice.
Yeah, proving that Fourier transforms is all you need, right?
Yep. So you can have your own custom spectrogram that you can try to augment based on the type of sound or the waves that you try to listen to.
So why does an NLP augmentation tool, which we just went through a ton of forms of NLP, why is this particular tool dealing with, waves?
Because of audio. Audio is kind of a sequence, right? So therefore,
Do you think,
NLP.
but do you think this is a audio first
I think so. It should be an audio. It is probably an audio first.
But they're using text data here, so it probably uses specific.
No. The point is that audio is also sequence data, right?
Yeah, of course.
So the same tools that you use for NLP, you also use in audio.
Has anyone ever done matrix or graph augmentation? Right, because that's the difference, right? You've got a point, you have a sequence, and almost everything in life is based like DNA and everything, right? All information in the world is sequenced, but then you also have matrixed or networked information, right? That's the next step after sequence. Is there any sort of graph augmentation?
I haven't heard of it. I know about graph generation. So I suppose, you could use that as a augment, to basically, if you learn the distribution of a graph and then you can generate a similar graph, then I suppose you could use it for augmentation as well. But I haven't heard of, a technique really.
This aug library has a lot of, it's nice because it's an aggregator of techniques, right?
Right.
Crop aug, loudness aug, mask aug, noise aug, pitch aug. A lot of them are audio. Yeah.
There is this library called as Augmentation for the computer vision. And there was I just discovered a Kaggle notebook where they actually did creative ways of, the way that different transforms applied for images. They did it similarly for NLP as well. I've just shared that notebook. It was pretty interesting. I just shared it in the chat.
Yeah, if you use it on the embedded space, right? Then I think you can reuse a lot of the image stuff, right? So any transform that you can think of. Well, I don't know if rotations and stretching would actually make sense, but they are both continuous spaces. So in that case, in that sense, I think there might be some, way to move.
I think I don't know how granular words, phrases, sentences, because in images it's only pixels. So
right,
interesting.
Does anybody ever try to put natural language into a grid format, to use vision stuff like this?
Well, I've seen CNNs being used. I don't know if that actually qualifies, but CNNs could be used in NLP tasks as well, right? Where you represent the sentence as basically like a two-dimensional thing with words down the rows and the embedding dimension along the columns, right? So let's say you have a word-to-vec kind of thing. So it's a 10-word sentence. So it will be 10 by 300 is the input that you will give for that record. But that's, again, not augmentation, though. It's just treating it like a two-dimensional object.
Yeah. Okay, Mayank, you have anything else going on in your mind there, or your work or anything? Okay. Well, we'll move on to Manny. You have any updates on your different projects or anything you want to share or ask?
No, not really. I've been trying to get improving the tokenization. Improving the routing performances on the East Asian languages, Chinese, Japanese, and Korean. And I haven't actually applied any transformers right now. It's only tokenization improvements. So I'm switching from the Japanese analyzers used from Lucene, to actually a specific library for, I think, Jiba for Chinese and Nagisa for Japanese, and then Korean, there is a separate library, Pi. So I'm just, switching to these new libraries and see how the improvements are going to be. So that's the experiment that I'm trying at the moment.
So is that word tokenization as opposed to subword?
I don't think it's a subword one.
Yeah.
It's I don't think it's a subword. It's
segmenting, right?
Yeah.
So you can't. So I know the whole subword came out of, and there's ML models for building tokenizer models, right? For subword models. But can you use that for the old, for the non-DNN stuff, for the traditional machine learning? Because I've always done whole word, with stemming and lemmatization and that kind of stuff. And I'm assuming that's more what you're talking about. Like, what are the models? Are they deep neural networks?
No, they are not.
Okay, so you're just doing more traditional tokenization.
Yeah. Yep.
Because I'm guessing
for the CJK. Yeah.
My guess is that that could be an advantage, not that you're going to switch now, but if you were using DNN models, is you could actually train your own subword tokenizer without a training set, right? For a subword model. Has anyone that, you know what I mean? So you wouldn't have to worry so much about having a tokenizer out there that actually works for your language.
But does subwords actually work for Chinese?
I don't know, but transformers. So I would look. Obviously, you can't use it for what you're doing now. But if I was in this situation, I would look and do using deep learning. I would look at transformers. They have the whole tokenization models. They have a bunch of models, right? That they have a whole section of their tools to do that. I just, I don't know what happens if.
Well, at least the way Chinese works is they basically write in these, the ideograms, right? So, but they write in an unbroken line of ideograms, and the reader is supposed to segment it, based on his understanding of the language, right? So, if the reader is supposed to know, for example, that these two ideograms represent river, right? And this one ideogram represents something else, right? And basically based on that, he will, and it could be more, complex processes as well, right? It could be going to the market, right? So this could be one ideogram. And so the reader, as he reads it, they do the segmentation of tokens and sentences on their own. It's like an unbroken stream of, these little characters. And they have apparently 3,000 of them. So segmenters typically use Markov model kind of things where it's all pre-segmented. Their training sets are all pre-segmented, so they know where certain characters end and certain characters begin, and they know them as like end of word and beginning of word. And using that, they kind of come up with a best guess of what the segment should look like. This is my understanding. Things might have progressed beyond this, obviously. So, yeah.
Actually, I have a question on the Chinese language. So I potentially could be working with the Chinese data, and the way I was thinking about doing it is just there are APIs on top of. You basically can use Google Translate at low rate. Has anybody tried it recently for like text for like technical data? Is it like good enough? Not for like somebody who's going to review it. So native speaker is going to review it after, but is it like good enough to use in the model?
I've used Amazon's thing. We can't use Google because we're afraid Google will steal our data. So, but Amazon seems to be pretty good, the Amazon Translate. But lately, the move has been more towards using the Hugging Face transformers that Gautam also used in our the JAX Flex thing that we did. And I think, and those translation systems are actually quite good apparently at this point, that people prefer to use. So I did a proof of concept using the AWS thing, but when it went to production, they didn't want to use AWS. They just used the Marian-MT family of models.
With Hugging Face, can I use it as APIs, or can I?
No, you'll have to download the model and then use it, locally. But it's very simple to download actually. So it's, if you go to Marian-MT, let me see if I can.
Yeah, I mean, I've used their models directly in Colab. Download them.
Right.
Crazy easy. All right. Well, Suji, just looking at that, is there anybody who has anything they want us to try to cover, or they'd like to present or share, actually, that they in next meeting next week? I mean, we just get together and discuss like this, and we have plenty to talk about. We don't need it, but if there's somebody who feels like they want to cover something specific. Okay.
Well, thank you.
All right, guys, is there anything else anyone wants to share or discuss?
Actually, I have a quick question. So I went back through the channel, and I couldn't find what I was looking for. So let me ask. So I remember somebody posted. It was I think it's a GitHub project, like or a library where you could basically highlight text, similar to how Displacy highlights text, but you could do it like with your own web page.
You can make Displacy highlight non-spacey text as well.
Oh yeah, I tried doing that.
Okay.
For some reason, like the color didn't work for me for that.
Oh, you have to assign the colors, right?
Oh, okay.
Yeah. So there is a colors attribute in the Displacy render where you have to basically,
because if it's my own meaning, exactly. I have to
Right.
But do you recall there was a library we discussed? It was about 3 weeks ago or a month ago.
Okay.
Where it was basically like a maybe I saw it somewhere else and I just like thought.
Yeah, I think you might have seen it somewhere else. I don't remember this.
Okay. All right. I don't have much. The only thing is I've noticed the empirical methods in NLP is like in a week, and they're actually going to do it live in Dominican Republic. Well, they're going to do it online and live in Dominican Republic. So I thought, well, that'll be like a good conference to go to maybe next year. It's an exotic location.
Ah, okay. Oh, physically go there? Okay.
Yeah. Well, this year they're actually doing it in the resort. So which was nice.
Okay.
All right, that's it for me.
All right, guys. Anything else before we call it a day, a meeting?
Darren, if you when you are posting that set of links, right? Can you take away all in the first example, right? The Twitter status. Can you knock out all the stuff after the question mark, please? It's just.
Oh yeah, you're huge.
Sorry about that. Yeah.
All of the arguments in there.
Yeah.
Okay.
Yeah, I just copied and pasted, so I copied all the other crap in there also.
Yeah.
Sorry about that.
No worries. All right, guys. I think that's it.
Cool. All right.
All right.
Cool.
Talk to you guys
See ya.
next week.
All right.
Take it
All
easy.
right.
Bye.
Talk later. All right.